Welcome to Chemistry White. Today we will see racemisation. What is the racemisation? See, when D isomer and L isomer of same optically active compound are mixed in 1:1 ratio, it means 50-50. We get a racemic mixture and the process is called racemisation. A racemic mixture is optically inactive due to external compensation. Next, when equal amount of D tartaric acid and L tartaric acid, which is an optically inactive compound, next the racemisation can be occurs by below the way. See, first one is by mixing, second one by chemical synthesis, third one by thermal racemisation, fourth one by cationic formation, fifth one by anionic formation. First we will see. Before, note, optically inactive solution is called racemic mixture. If we take dextro form of tartaric acid, its rotation is plus 12.4 degree. If we take levo form of tartaric acid, its rotation is minus 12.4 degree. For example, see the example below. This is the right side of the, it means a clockwise rotation, dextrolactic acid plus 12.4 degree. This line is plane polarized light. This is denoted rotation. Just like the levoacetic acid, it is going to anti-clockwise. So we can give minus 12.4 degree. This rotation is minus 12.4 degree, a plane polarized light. This is the plane polarized light. What is the specific rotation? The specific rotation, see, 12.4 degree minus 12.4 degree, both are cancelled out, we get 0. This is the specific rotation. We will see the specific rotation after lesson. First one, by mixing. We know that thermodynamic equation del G equal del H minus T tilde S. If delta G is negative, that is called spontaneous process. Here we need delta G and minus T tilde S. So no need delta H. So it is going to 0. So that is why no need delta H. If we take temperature T at 300 Kelvin, so delta S is entropy changes, but in this equation delta S is going to R denoted racemisation. So delta S equal to minus R. This is going in this reaction, entropy is going to negative. So delta S mixing equal to minus R x1 ln x1 plus x2 ln x2. Now if we take x1 is 0.5 mole So x1 equal to 0.5 mole is half mole, x2 equal to 0.5 mole is half mole. Now substitute the both value. See here both values equal to 1. So minus r ln of here 1 is we can express L1 is it is called ln. Ln means natural logarithm. Ln n1, this 2 is going to ln 2. So minus r ln n1 minus ln n2. Here both is natural log. So we can multiply with 2.300 ln 1 minus ln 2. See the here ln 1 equal to 0. So ln 2 equal to we get 0.3010. So equal to minus r ln of equal to 1.4 calorie by mole. If delta G mixing equal to delta H mixing minus T delta S mixing. So minus T delta S mixing, so equal minus 300 Kelvin into 1.4 calorie by mole equal minus 420 calorie by mole equal to minus 0.42 kilocalorie by mole. Here when we convert kilo to chlorine, so minus 0.42 calorie per mole. So del G mixing is negative. It is negative means it is denoted by spontaneous process. Delta S mixing is a spontaneous process. Second one, by chemical synthesis, the optically inactive compounds undergo chemical conversion by two equally possible different routes to give a racemic mixture. For example, see example 1. The R is denoted methyl group, we know that. CH2COOH carboxylic acid. This is the alpha carbon. When treated with bromine and phosphorus, we get RCHCOH Br. We are going to attach it with the CH. There is no chirality because the two H2 atom attached to the carbon, so it is a chirality. Here alpha hydrogen replaced by Br2. See the equation. So we can get RCH2COH Br2 phosphorus or CHCOH Br. We can write this equation stereochemically and it forms two roots. COOH, CCH3, HH. If going to left side, phosphorus and bromide, HBN reaction, we get dextro. This is the dextro compound. This is root 1. If we going to right side, phosphorus Br2, HB that reaction. Sorry, I written mistakenly. This is Z, not N. So we can get BrCHCOHCH. This is the level root 2. In this reaction we will get 1:1 ratio. It means 50-50 percentage. So this is racemic mixture. Next example, this is the carbonyl group, this is the halogen. So we can get alcohol and halogen. If carbon comes at double bond, it is sp2 hybridized and its geometry is trigonal planar. See below the example. See double bond O CH3 H. This is the sp2 hybridization because here double bond. When treating with HCN hydrogen cyanide, we can get CH3 OH CnH. If HCN going to dissociate, that is, we know that already, it is going to dissociate H plus and Cn minus. So we can get C double bond O CH3H sp2. We can get here, break the molecule. This is the dissociate H plus and Cn minus. The Cn minus going to attack the carbon at two roots, because this cyanide is getting one negative charge. This negative charge is going to attack and we get this form or this form. First form CH3 CnOHH or CH3 OHH Cn cyanide. Here we get both equally ratio at 1:1. This is called racemic mixture. Next is example. See here, C double bond O CH3 H, here one methyl group attached with oxygen and one hydrogen atom. This, if going to left side, treating with hydrogen cyanide ion, we get CnHHOH, this dextro form. If you go into right side, treated with HCN ion, CHCOHH-CH3. This is the Leber form. Note here, this is HCN dissociate H plus and Cn minus. Same thing like this. Next, by thermal racemisation. On thermal or heating, the homolytic cleavage takes place in the molecule, resulting is free radicals. The racemisation of the radicals results in racemisation. For example, this is the penyl group, this is the alpha carbon, here this is the chlorine, this is the methyl group, this is the alpha carbon, this is the beta carbon. So this name is, IUPAC name is alpha penyl ethyl chloride. When they heating this molecule, this is going to break blow. See, here break the bond CH between Cl, bond breaking. So CH3, it gives free radicals, pH C radical H and CH3. Now free radical Cl dot is in p orbital. See, we can write this is C, this is the carbon, penyl group, methyl group, hydrogen. This free radical going to attack in the carbon. because carbon it makes 4 bonds, but here 3 bonds only. This chlorine radical going to attack back or front side. This is the sp2 hybridized trigonal planar. It is going to attack the back side. We get like this. See, pH going to this place and this CH3 going to top. If we are going to attack right side, it means front side. We get like this, HCH3 Cl going to attack this carbon. This Cl radical going to attack this carbon. Here see, this carbon has only 3 bonds. Here also, because going to this chlorine going to the attack. Chlorine is as negative charge. This chlorine is also negative. So we know that the chlorine valence electron is 7. So it is going to pull the 1 electron because it is going to attack the carbon. Here we can write this like below. C6H5, this is the phenyl. C6H5 means phenyl. Phenyl, this is the alpha carbon, methyl group chloride. It gives phenyl, CH radical, CH plus Cl. This name is alpha phenyl ethyl chloride. See below. This is the phenyl group, CH5, CH radical, CH3 plus Cl radical. It gives 2 ways. One is going to dextro, another one is going to levo. This is the dextro form, this is the levo form. Next, by cationic formation, the optically pure substrate generate planar carbonium ion which is undergo racemisation. For example, CH3, this is the methyl group, this is the phenol, CH, this is the Cl. This carbon is asymmetric or chiral carbon or non-superimposible carbon, because there is 4 different atoms or groups. So when treated with SpCl5, so we get CH3, CH positive charge, this is the pH plus SbCl6, this get minus charge. Because 1 electron going to add with Cl5, so this we get SbCl6. Sb means antimony. Here antimony pentachloride, this is the antimony pentachloride, this is the antimony hexachloride. Here antimony pentachloride SbCl5 is going to break the Cl bond, blow like this. So this chlorine is going to attack the back side, so we are the chlorine going to attack the front side. See, front side. So we get, this is the sp2 trigonal planar, this is also sp2 trigonal planar. See the diagram, this is the trigonal planar. Here bond breaking, here bond breaking with carbon and chlorine. It gives CH3CH positive ion and penyl group plus SbCl6. This is the antimony hexachloride. So the Cl going to this take the place, it's going to two-way and it gives two possible compounds. This is the dextro form, this is the levo form. Here LaVO, this is not E, by anion formation. Optically active compounds undergo racemisation when heated with a base through anion formation. CH3 COH OH. This is the hydroxide ion. It is also CH3 OH HCOO minus. It is give two form below. CH3C minus, it is going to attach with this sigma bond. So here we get double bond, and oxygen get the minus sign. See right side, same thing like this. This carbon going to double bond, so this is get O minus, and here O minus double bond. It is release the H plus ion. The H is going to attach with the carbon. See below. So we get two form, on a dextro, another one LaVO. This is LaVO, LaVO. CH3COH HCOH CH3OH HCOH. This is the LaVO form. Another example, 6H5. This is the penyl group. This is the carbonyl group. This is the methyl group. ET means ethyl group. When treating OH hydroxide ion, it gives 6H5 penyl. This is carbonyl, C double bond O, again CH3, the methyl group. This is the ethyl group. This ET is, both are same, please don't confusion. Prefix is A, ethyl is ET. It is simply denoted. This is going to analyzation. Analyzation, see the analyzation. If going to C6H5 penyl group, and here going to the double bond CH3C ethyl group. At the same time, at the right side C6H5 C double bond O CH3, it gives, this is the dextro and this is the LaVO form. C6H5 C double bond O CH3 ethyl group. This is the dextro form, this is the LAVO from LAVO. Thanking you all the best. More video on the way. Please subscribe the channel. Have a nice day.